Unc needs his supper right.
All right, example 9.4. Let's do that first. Let's do 9.4. This is displacement current. Let's just write that out. Displacement current. Okay, so what's this? So we have a parallel plate capacitor with a plate area of 5 centimeters, plate separation of 3 thing. Okay, so we have a parallel plate capacitor. So it's basically this guy. It's a parallel plate capacitor. The distance between them is 3 millimeters, and the area, I'm gonna call this D actually. So D is that, and then A is what is it? 5 centimeters squared, which is basically 5 times 10⁻⁴. Reason being is because if you have 5 times 10⁻²² squared, because -2 is a centimeter, you square that, you get 5 times 10⁻⁴.
You know, I just learned that today while doing the EE 320 320 final.
The 320 final or the 360?
320.
Okay.
You know the portion of it where you have to fill out the chart?
Yes.
No.
Yeah, because you have like 500 centimeters squared, and then you have to make that into meters squared.
That was
Dude,
fun.
I haven't even finished the 320 exam. Oh, let's see.
I'm just so glad he gave an extension, otherwise I'd be dead right now.
Same.
Let's see, what else do we have? And a voltage separating them. What's the voltage? The voltage is what's the voltage? It's 50 sine. Oh brother. 10 cube T. All right, so we've been going at this so far for 2 hours. What do you guys think? Was this very good with our time? I hope it
Yes.
was.
I'm just gonna say it would have taken me far longer to understand the concepts that you
Yep.
explained, so thank you.
Now
I
this is for
appreciate
all of us. This is for all of us because I need it as well. Because this is, if you could somewhat explain it, you kind of know what's going on. What do we have here? So, okay.
I'm so confused with all this stuff.
Just remember, they have Pushkin next semester.
For what?
FYI, for this class.
Oh boy, that's who we were supposed to take it with
That's who we were.
at the very beginning.
Is Pushkin better or worse?
He has good reviews for physics, not gonna lie. For physics, I don't know about the other. Pushkin
This is
True, something like that.
more or less, so I guess it could work out.
I'll say this: I hear that his exams are a little bit tougher, and given how the professor, this professor gave these exams, I think we kind of got off the hook a little bit.
True.
I'm just gonna say Alien Lopez screwed us all over this semester. Freaking 360 and 330 and 320 and 432.
Hey, you know, that was the only thing that we had to go for. I don't know
Dude,
what.
for me to take 320, I had to take a physics lab together with all this, and 2 labs, one for a physics class that I took like a year or 2 ago. No thanks. I'll wait till next semester. It's such a ridiculous thing, and with all the credits that transferred from Reno, I have to take more general classes, and she wants me to incorporate that into my like regular semesters, but I think I'll just knock it out all in like the summer semesters and have it done with. I can't do this and at the same time take a philosophy class.
I hear you, bro. That is too much.
It is too much.
There you go.
think
Okay,
she's
so
she's our only counselor for this, right? For electrical engineering.
Yeah. Every time I'm in a meeting with her, it's always us just gossiping about, like, oh yeah, you don't want to take him. Oh, he's probably okay, sort of. You want to do that? Okay.
I think she has good reviews overall of like professors. Like I've taken like circuits 2 over the summer with a guy that's like he's basically the pupil of Baker, Peter Skelly.
Mhm.
Oh,
And he's so really good.
Oh, James
Yeah,
Kelly. Yep.
yeah, he's good at what he does.
I like that. I know David was another pupil, David Santiago.
Oh, him?
Mhm.
Oh, he's really great.
Yeah, he made the MATLAB a lot better. Oh my,
He definitely helped me.
Oh, all
Okay.
right. So what do
So
we know?
then for
So
the
this is.
solution, what does what's D again?
Okay, so I will explain everything right now. So this is epsilon. So epsilon. So
Mhm.
everything above the red dashed line is given to us. So the distance and the area and the voltage and the epsilon region. So epsilon equals 2 epsilon naught. And so now what we need to do is find the displacement current at ID. ID is given by JD times S. JD is given by the derivative of the electric flux density. The electric flux density is given by epsilon electric field. The electric field, we have voltage equals ED. So we can go ahead and say that E equals V over D. And we can go ahead and stick that into our D formula. So D is equal to epsilon V over D. And yeah, that's pretty much that. And so now if you want to do JD, that's
Man,
equal to, see, so we have to take the derivative of D with respect to T. And we understand that, I personally, what I do, I just go ahead and just go for it. Like, I just stick the whole thing in there. Like, I know the book, they're like, playing with just the letters and all that, but I'm just going for it at this point. This that over D. All right, so that's that. So what's the derivative of this with respect to T? So we have to basically take the derivative of this guy. So what we're essentially doing is we're taking the chain rule. So we have to do let's see. So this will be cosine. So this is 50 epsilon times 10 cubed times cosine of 10 cubed t divided by d. I think that's how you do it. I think that's reasonable. And now we have to also take this and we have to multiply this by the area now at this point. Um, because we have JD,
Oh,
so
the surface
JD
area.
times
That's
S.
what S stands for.
Yeah, S is surface area, my bad.
Wait, but
So
wait, how do you get? It says get capacitance from epsilon S over D. What?
uh
yeah.
I'm gonna try this way and see if it actually works. Because if it works this way, then it's fine. Because they're basically just saying, hey, epsilon A over D equals C. So they just simplified the equation that way. But I just went ahead and plugged in all the numbers, and that's it.
Would you have
Uh,
recognized that in a million years?
uh, I don't know. I would just plug in numbers. That's all I would do. I would just plug in numbers at this point, honestly.
Sounds good.
And so
You got
that's what I'm gonna do right
anyone
now.
else?
no.
So 50, what's epsilon? Epsilon is 2 epsilon naught. So 2 times 8.5 times 10 to the minus 12. And then we have times 10 cubed times cosine 10 cubed t. Yep, cosine 10 cubed t uh, divided by d. And d is, what is it? D is 3
3
millimeters. So it's
millimeters.
3 times 10 to the minus 3 times s. And s is 5 times this. If anyone wants to throw that in the calculator for me.
It's 147.4 cosine 10 to the third. T
Did
and
you
A.
just read that from the book?
No,
How do I know?
I
Once
calculated it
again.
in my head.
I smart. Okay.
Oh yeah, it's 2 times. Okay, you do X's for times. Okay, gotcha.
I see.
No, he's doing 3 cross 10 to the third.
I see what you did, but holy.
Let me just get my calculator real quick.
Oh,
One
I'm
second.
calculating it right now.
Oh, okay.
Thomas pulled out the NASA calculator.
You guys know exactly what kind of calculator he allows for the exam?
The normal scientific calculator.
So, like, is a TI Inspire
I don't think
graphing calculator allowed?
I don't think he cares.
It won't. It's not allowed. He said no.
No?
Oh, he
Is
said
that
no?
5 times 10 to the negative 4 or 9?
4.
I used my same calculator last
Is it
time.
really not allowed?
I
Come
got
on. It's,
1.475 times 10 to the negative 10th.
Yeah, just move the decimal place.
Oh, but nano.
Yeah, so basically, if you take that answer and you multiply by 10 to the 9, you can basically get 1.47. All right, so this is right. There you go. All right, this is good. So do this and you get the answer.
Yeah,
Yeah,
just
so
plug
just
it
throw
in.
it into the formula and whatnot. Don't even
Yeah,
care about
Michael, is there any way you could download this, like, or take pictures and just send it? And just,
I could download this document and send it to the chat. How's that?
Yeah.